Yeah, hello everybody. We're continuing our stream basically today, which I finished. But yeah, we're continuing it for now. Yeah, I wasn't unfortunately able to figure anything out. I did have to make a couple of calls though. But yeah, whatever. Why does actually Twitch show that I'm offline? It tells me I'm offline, which is obviously false because all the restreaming stuff works. And now I just received an email that the live stream on YouTube is working. So that yeah, that's kind of messed up. But and why the hell is everything so laggy? Why the hell is everything so laggy? I don't know. I don't get it. Uh, channel. Why the hell doesn't it work? It's like so slow. Everything takes like whatever a decade to load. It tells me I'm offline. Right, but the YouTube tells me the connection is excellent. So it should hopefully work. Reconnection successful. Everything's connected fine. I mean, I figured out what root on the chat. Yeah, it works. Yeah. I accidentally figured it out because the accidentally the Windows firewall just asked me whether I'm okay with Nginx listening to the port, and then I realized, oh, that's how it works. Because I did something similar actually in Nginx, but for some reason I wanted to do it on my server, but it told me that the RMTP is not supported. So yeah, for some reason whatsoever, the RMTP was not supported, and yeah, but yeah, I purchased the root on every stream server for I think $1 it was. Yeah, just $1. So not a big deal actually. And but yeah, so under the hood it just starts the Nginx with but I don't know, with some uh data with some pre-made configs. So yeah. Wait a second. Let's go to dashboard to manage the stream on Twitch. Yeah, here we go. Here we are. Yeah, so it works pretty fine. I don't think I will get any views on Twitch because Twitch is not a programming. It's not a programming platform. It's not a general. It's more of a gaming platform. So yeah. So where we stopped for now is the list. And yeah, I actually have no idea what to do with it and how to do it, how to implement it. Really. Um, Maybe you could ask ChatGPT what it thinks. I mean, I really don't like the whole boxing stuff. I mean, it makes sense, but I don't like it. It makes sense to some degree, obviously. The fucking advertisement, yeah. Go fuck yourself. Your advertisement. Yeah. Google Maps or Google whatever advertisement. Yeah, it's just hilarious. Yeah. Now here we go. So yeah. let's ask maybe ChatGPT what it thinks about. Obviously, I cannot show you again the ChatGPT, unfortunately, because maybe I will expose some proprietary information. I'm trying to also yeah, use and ask ChatGPT about. Yeah. So in Rust, I have a general I am working on custom data type wrappers, which all are basically structs, but they implement one specific interface with a function to get and to set a value. Obviously there. Wait, I will skip this song. Yeah, that sounds better. Obviously, the return types of these functions may vary depending on struct and implementation of the interface. I had a big trouble using boxes and etc. So what would you suggest? Please write some code. Thank you. Yeah, no, I don't. I don't say thank you to ChatGPT because I'm paying his ass to do the job. So yeah. Data type, value, good. Or integer type, yeah. So that's what it suggests me to do. Value. So that's what it suggests me to do. That data type value. I mean, it was possible from the beginning, but so yeah, let's remove the TF list, the fuck list. Yeah. Yeah. Fuck, we have to implement the whole stuff from the beginning, but load boolean bool. And why the hell is it marked as non-used? For real? Why? I really hate it. There's some bullshit going on with the compiler. Whatever. Yeah, it works fine. Data value and the date type value. So now I have to re-implement the whole bullshit. Yeah. Data type.rs. Oh, huh? Didn't I just rename it or something? Hello? Hello? Use super data type value. data type value. Yeah, that's what I thought. Like, there's no way it works. Let's keep it blank for now, to just test whether it's compiles or not. Oh yeah, let's return float. Oh, dot clone. It's possible, right? Yeah, yeah, it is. Float. We have just the same stuff here. Just the same stuff here. Use super data type data value. Value data type value first, and then we just oops. Okay, just work, right? It's in 32, but it's 6. It should be 64. But yeah. Now it's fine. Is it? Yeah, it is. Value downcast. What? What the hell? No. I'll leave it this way for now. Data type value clone. Um, Argo run. Where do I use the downcast ref? Oh, I think there's the float. Where? Where exactly? Oh, it's me? Huh? Okay. Change. Nice. Okay. Whatever. I mean, it's compiled for now. Okay. 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 Wait. The music is a bit too loud for me, unfortunately. Yeah. So yeah. Yeah, let's go. Let's proceed with yeah, the where where we had a problem, and it was a just wait a sec. Main mod. I hate the snake case. I just hate it. I just fucking hate it. Right? It's vector of a dynamic any. Isn't that exactly the problem we had? Vector of data type. Isn't that exactly the problem we had, isn't it? Alright, I mean it's called list, list, list. Isn't it exactly the problem? No. Okay. TF. List. Fuck. List. Yeah. TF. Mode. TF list. I'll use to list. Right. Oops. H replace Control H replace with D list. Right, works. Our go run. Finished. Here we go, and now the real butt fucking starts. Data type, right? So now it gets unclonable. It's where the real fucking around starts. So I have to delete the whole thing here. Turn it to list. So the string we don't need. Yeah, create a vector. Value. Yeah, it's unclonable. Yeah, we'll make it go in there later. Length, no, we don't need it. Yeah. It's a list, right? Um, okay. And so hopefully it will help. Around, you can add clone box method to your data types trait, which allows each implementer to provide a cloned instance of itself. This approach avoids direct cloning using the box, requiring each any percent per sync. Expand the data type trait to clone. Uh, Derive cloud. Oh, huh. I mean, doesn't make any sense for me, but whatever. Who am I? Um. So it derives clone. It can derive the clone. Can it? Now it can. Now it can derive the clone. Okay. I mean, I don't think it's that optimal, but it seems that it kinda works. Which is everything we want, right? So I mean, it seems to work, and list dot clone. Can I do it? I mean, can I? It seems that I can. It seems I can. But that's the what what the catch starts. Great. Let's into it. Does it work this way? Well, it seems to kind of work. Since it's a list set value. Um. Nope. I'll let you list. Nope. There is an error. Where exactly? Oh no, no errors. Actually, no errors. Nice. Nice. Okay. I mean, I still have no clue how it works, but it works. Let's implement clone for box. So yeah, I'm extending the I can create a clone. Yeah, for the box dynamic data type function on cloning itself. It basically clones the box or what? But exactly, I mean, it could cause like huge problems later. It could really cause some huge problems later, right? Yeah. From string, uh, and get length, not the use size, but use 4. Yeah. And push L. Push. Right. No such thing. Okay, let's state just by push and yeah. Actually, I don't want to for it to return, want to return the data type value actually. Index out of bounds, good. Element is a data type value. String push from date. Oh no, I don't want to get actually data. Hey man, okay, right? Sorry. I know. I mean, I have a pretty huge display, so really hard to read. Sorry. Is it better? Yeah. So I don't want actually the value itself to be returned, but the yeah, right. Thanks for coming. But the date, it actually does it work this way? Return cannot be unboxed. So unfortunately we have to return the box. Return box. And I mean we could theoretically try to, since we just implemented, I don't know why is this code marked as unused. It is used though. It's the core interface for the whole stuff. Why the hell is it marked as unused? Hell yeah, I can't use the Rust. As a C++ Java guy, it's a nightmare. It's a total nightmare for me. Like you write something in Rust, yeah. Add element, get element and add the element. Okay, that's for now. That's everything we want for now. But I guess, yeah. So you send a sync. Whatever this code does, it send plus sync. Again, I have no idea what it does, but it seems to work. And this code, I have just a bit idea what it does, but it still seems to work. So list. Again, we have to rewrite all stuff. We want to return the dynamic box, and we want to accept the dynamic box any. And again, we have the whole bullshit to be redone here and re-implemented, because again, no such thing here, no such thing there, no such thing over here. I mean, I could have theoretically commented out the files to like make changes to one file and wait until I'm done. So it returns get value, set value. It returns a box. I hate the box, but yeah. So it returns the boxed value. Yep, makes sense. Accepts the box value. Nope. Value. For expected struct string, found struct box. Okay. We'll come to it later. And clone the box. Yeah, it just this function's constant, so I mean, doesn't even make sense to keep it here. I mean, I could theoretically. Wait a second. Data type, could it switch it just to put over here? Is it? Will it work? It's not the file is not included anywhere. Fuck yourself. It's not about being included or not. It's about being yeah, just wait. Yeah, we'll come to it later. Hello everybody, thanks for joining. Yeah. It's gonna be business code here. No, we're gonna be again switching to box. Any yeah, soft list of clone. It's pretty unsafe, I guess, so we'll leave it out for now. And the set value. Oh, yeah, we have to return something, obviously. But we don't have to write it in here. We just have to return shit. Return box new. Can I just do it this way? I can. Oh, so the it's basically the same as null, even though there is no official null here. It's null safety called. It's called null safety, but any. No, and there will be there is it. There we have it. And the same to finish what's in here. Box, right, good. Run, I mean, for me, again, it's complicated to run, write type cargo run the whole time. For me, it's much easier to write make. Again, this is C++ guy is not implemented in itself. The tray data type is not implemented in itself. Data type. Is there any the following other types implement trait required to cast? I really don't want to like copy paste this code everywhere because it's just the same. Isn't there any way like to keep it abstract like in Java or C++? Is there any way? Excuse me. Okay. Not for all data implement the clone box method. For T, where data type. Data type. Self will get value. Self, I mean, will it work? Wait. Nope. Won't. Conflicting implementation to list. Right. I'll just copy paste it for now. I'll just copy paste it for now everywhere and there. Then I'll maybe do how quick refactoring session or I'll do a huge refactoring session where kind of fix the whole stuff here. So yeah, we have lists and we can put refactor the whole stuff again. That's what I did from the last commit. Please don't kill me. Yeah, I know my like commit descriptions, they're like horrible, but whatever. These are some yeah, start initial commit, start working on this mess. Have no idea how it, for some reason it says dear, not idea, it's dear. Yeah. Other finger this stuff again. Move back to boxes. Extended a box method to be cloned. Hope it's correct. I mean, I've heard some rumors about that. It's impossible to write bad code in Rust. And I hope it's true, because if it's not, oh man, oh boy, I could do a lot of mess. So okay, right, string, we haven't, we have to first of all downcast, unwrap and clone, and it works, right? The same with the integer. Nope. It's the downcast. So we have to downcast it to the 64. It's right. It is. Yeah, it is. 64. Good. And now that's where the hard stuff comes. So yeah, we have to loop through the list and copy each element. So yeah, that's the new list. Good. Yeah, so we're cloning, pushing and cloning the element and pushing the cloned element. Yeah, makes sense. And this it sets the value, and now it's actually the opposite. Let mutable new list, so it's not effective. Right, makes sense. Good. Makes sense. Run. Everything's fine. Okay, what does my stream look like? Yeah, it looks decent. Wait, maybe I have to. Oops, sorry guys, sorry. Yeah. No, it looks much better. So here we go. Yeah. Yep. It works. So what's next? What's next? Actually, I'd love to write some kind of testing suite, just to be sure that it works. Data type tint, tfloat. Oh, float. Huh? Tfloat. Oh yeah. From load. Yep. And this account, and we have the list, which is from string, from list, data type. Yeah, as simple as that. Oh, and yeah, we don't actually get a new list and do the copying. I mean, we would implement is a feature to copy the list. I mean, it's obviously should have been implemented here, but yeah, whatever. So we're copying the list now here. I don't actually know which it could get an undefined behavior. I don't know Rust again. But if there is a list within the list, because the list itself actually implements the data type interface. So technically, there can be an endless amount of lists inside lists, and it can be forever. So for every object, the copy is invoked, right? The clone is invoked, and then the question is, if there is a sublist and there is a direct clone, not like my fancy clone here, but a direct clone is invoked, does it work? Or does it copy not only the list but also the content of it? Because from what I know, it does not. And if it does not, it can become a problem potentially later. If let's implement clone or list. Oh, for vector, sorry. For vector data type. And I messed up. Where exactly? This file. Fuck. Shut the fuck up. Sorry. What? Vec is not defined. Oh, oops. Use. Huh? Oh yeah, have a bunch of new viewers. Hello guys. So the error we're getting is from yeah from load. Oh, you can actually specify like this. Okay, like all right, it works. It works fine. Run, messed up. What exactly? Only traits defined in the current crate can be implemented for types defined outside of the crate. Whatever it is. Okay. Implement a clone function for a vector. Let's see what it tells us. Huh? No. Implement clone or vector. Huh? Should work now, but it's just the same code. Just want the FDA. And what will DI say? Struct data type back. So I'll create a new data type vector. Also data type vec. Pop struct. Okay. good. Models, pub, data type back. Nope. Pub, use data type back. Alright, seems good. Now here in the list, so a use super a top, okay, cannot initialize a tuple struct which contains private fields. Constructor isn't. Create a struct with a type field. Initialize the struct. Topic. How? No, I didn't actually want to move for now. Nope. Oh, that's actually that's actually much faster than like running in a loop. It's actually much faster than running in a loop. Pub. Fen. Copy. Vector. Save. Copy vector save. There's a tab. Copy vector save, right? And in the list, to use copy vector save. So now. Return a list, copy vector save. Save follows the push. Mutable self, use size of clone, right. Copy vector save. Self at list, right, and return it, and just the same is for the set value. It's a get value. Nope. Let the list equals vector. New instantiate new one. Simple as that. Copy vector save. Oh, yeah, it's not even necessary yet. I mean, I could, for example, write no return here. That would work fine, or not. I don't know. I know the return is actually isn't mandatory everywhere, but oh, it compiles. Good. Yeah. So now the part which seemed to be hard enough is not hard actually. It was one of the easiest parts. String. Oh yeah, I get the get string, get integer, get float. Maybe let's implement them also. But it should be implemented here. Get string. Yeah, new element, get list. Int load, and now the main arrays. Yeah, it just works. So yeah, float 10. Yeah, why is it 10? Let's check. Hi. Green. Right. Yeah, it works. Nice. That is function for us open the backwards vector the vectors. Yeah, it will be updated in future. It will be updated in future. Let it mark. Let it mark those stuff. To do. Should be updated in the future. Right. Should be updated. So yeah. And for the Tetroflow project, in case Samba, I don't know, have you visited my streams or not? Because yeah, because I was telling about the software I'm writing, I'm working on, which is my open source project. It's currently written in C++, but it's not complete, unfortunately, but it's alpha ready. So some of my colleagues already use the project, the C++ version of it. But yeah, so what I'm doing here is a Redis alternative, a key value storage, an in-memory key value storage, which is very fast. And since I'm using runs, it's very secure because, for example, Redis, it actually runs on I think POSIX C99, which it's even not C++, right? It's just the bare C, and I mean the Redis is running on bare C. I mean, first of all, you could imagine how many possible bugs or security risks they are, because yeah, I don't say that Redis is a bad software, right? But the one thing I really don't like about it, it's that it's semi-open source, right? So it kind of opens its code. You can kind of read it, and you can kind of install the the Redis, but first of all, there aren't as many features in the um, open source version as in the real as in the production one, and they have, I think, much more stuff, much more features, a web interface, etc., etc., etc. Some replication methods. I think Redis by itself is a pretty solid, point of failure, because in most applications there's just one. I mean, I don't think that open source Redis even supports the replication. I'm not sure, but I don't think it does. Yeah, so again, um, I don't like it, and there was a demand, because again, some of my colleagues told me they haven't managed, they weren't able to find any good alternative for Redis. So yeah, and I thought, well, I could learn something. Now I have a pretty decent knowledge in C++. And well, I visited the Rust conference at the university where they encouraged us to use Rust, and I was thinking like, okay, like hell, let go, let's try. And yeah, I kind of these 2 days kind of suffered a lot, and I mean really a lot, but yeah, let's see. Let's see what we can do about it, right? I know that the Rust learning curve is actually it's very steep at the beginning, so it's really hard to begin, but it gets in like 2 months development, you can like basically write anything in Rust. So yeah, again, let's try. So what's the next plan? The next plan would be actually to create a tables. Yeah, it would be a difference to Redis, because Redis has no tables. Yeah, it's the red display. Yeah, yeah. Please do not wonder. Yeah, I'm running Windows now. Yeah. So wait a sec. Yep. You're looking for the Redis GUI. Yeah, first of all, I wanted to take a look at the Redis interface, accept all. Yeah. Blah, blah, blah. Oh, Redis admin. Hey, isn't there like an official GUI? There is an official GUI for Redis, isn't it? Yeah, whatever. So, yeah. Solutions. Products, Redis Cloud. I think there was like this GUI where you could split the data, but yeah, whatever. Yeah, so we're gonna be splitting the data. We're not gonna be storing everything in a one table. We're gonna be splitting the data. I'm not actually sure for now how. But I guess we'll create something like yeah, tables. And every so wait a second, I will draw it in paint or something. Yeah. So there in Redis there is one basically table, and that's it. These are entries, and there is a single threaded worker which gets the request and updates it, or does whatever. But there is one but. Yeah, so first of all, it's done to that's exactly how I done it in the C++ version. So what I did is there was a runner, there was a thread which had a queue, And with mutual exclusion protection, with mutex protection, with the racing condition protected from racing conditions, all the other I think server threads, etc. They added to the queue data, and then it just stacked up in the queue, and there was this runner which yeah, executed it and applied a table, and on execution ended, it invoked a function which returned a result to the socket. Yeah, it's just a normal bare Unix socket, but here I think I will use something some wrapper around it to make it portable to Windows or other non-POSIX system. And so yeah, we have to create a table. Table. Yeah, and that's the good question. How we have to structure it, and the data, and we have obviously we also have to create the core itself. So, maybe some hash map to store the tables. I don't know. I've seen some pretty oops. Yeah, I've seen some pretty good wait, I will hide it. So I've seen some pretty good Redis Redis interfaces where you could really like split it into the tables or something. And yeah, what I want to do now is basically every table has its own running thread. Every table has its own running thread. And it's basically being decided what portion of the table is what range, what thread it's what data it affects, and then it will be pushed to the queue of the thread, and yeah, it will work. I even have a hard time thinking how I would implement it in C++ or in Java, and I have no idea how I would implement it in Rust. So yeah, let's create it. Okay, table.rs, a mod.rs, mod.rs, table, table, so struct table, yeah. Again, I don't know how to search for these tables. Maybe also using a hash map, but there is a slight problem that, for example, a table hash map in Rust, for example, is a bit it's actually kind of slower than the C++ one. I think it's called unordered map. It's much slower actually, but on the other hand, I think the hashing algorithm, which is used in C++, is the is not as strong as the Rust one, which causes more collisions, which increases the searching complexity. Well, I don't know. I really don't know. So yeah, table. Let's leave it blank for now so we can both think and write at the same time. Struct table and entry key value. Right. Okay, makes sense. Key value. Well, first of all, oh, got a message. More data types. Super weird work. Okay. Okay. Works. At least seems to. It seems to work. Yeah. Table entry. I really don't know how to do it in this case because I mean we could do it this way. I think I'll also have to expose an HTTP port to and run a Prometheus on it to collect the metrics with Prometheus and with Grafana. I think it would be, yeah. So let me think. Okay. Using the hash map, optimize. I look if you need more consistent iteration order. B-tree map. Hash map versus map. I think B-tree has a larger access time. I think it's O log n or something. Associate order keys with a material value. You want the cache. You want a map with no extra functionality. You're interested in what the smallest or largest key value pair is. No, I'm not. Define the largest or smallest key. No, I'm not. You want to be able to get all of the entries in order on demand. No, I do not. You want to map sorted by its keys. No, I do not. Yep. Yeah. I think I have to leave it out because I mean, it seems to work. So rewrite log. Some imports, right, wrong. No. It works. Blah blah blah. So yeah, there's table. So yeah, log, and there's the string every log. So I guess every log is something like mutex in the C++, where we tell it basically. Yeah, it's right on read write log protected. Yeah, so but since it's single threaded, no actually rewrite protection is necessary. Yeah, so we'll be using the table. And sorry. The one thing we're gonna be first of all the string. I mean, it can't be. It's possible that the string is slower. You have to hash it, but I hope the standard collection hash map is fast enough. I hope at least. If not, I'll have to figure something out. Oh, what's it's telling us is implement the table. Oh la la, there's a bunch of implementations. So new. What is about this new data hash map? I mean, I could new capacity size use 64 self Can I cast it? Yeah, I can. And can also overload it. Uh, a fun, no. New. Oh, I cannot overload it like in Java. Maybe because we're in Java, but whatever. It's not Java. Oh, capacity. I didn't do it. Oh. So there's insert, right? Uh, get, move, get keys. Okay, good. Get values. No, we don't want it. Get size and clear. Remove. Oh, against key. Boo. Yeah. So we have it. Actually, not that hard. Pretty. I mean, it's very similar to C++ from what I see here. It's tree.cloud connect. Yeah. So yeah. It's alright. Again, it's very similar to C++ from what I know. But the question is, use a specialized hash a string as a default is a SIP hash, which is a cryptographic hashing algorithm designed to resist hash collisions, but not optimized for speed in every use case for non-control. Advertiser was speed is a priority, which is our case. It is our case. Dependencies. I wanted to write pop get. Pop, but pop, I wanted to write pop get, but pop is Flutter. Cargo. I think it's get. No, it's cargo. Cargo install a hash map. A hash map. Oh, what? But is it called like? Is it a hash or? Yeah. Oh, is it just a hash? Not a hash map. It's just a hash. It's case sensitive. A hash. It says no binaries, for instance. Oh, it's cargo add. Okay. Lovely. Okay. Oh no, it's not the normal, but it's inline always. What does it mean inline always? What does inline always mean? In Rust, attributes suggest that the compiler should always inline the marked function regardless of what else compiler optimization path would normally inline it. Means the compiler tries to insert the functions code directly at each call side instead of creating a separate function call. This can reduce function call overhead, potentially speeding up the execution. That's what we need. Makes sense. It make a frequently called small frequently called function. Yeah, that's exactly what we need. So no, you don't create it. Oh. Get size. I don't think it will be frequently created, but whatever. Oh, I mean, these are small functions, which will be sometimes executed. Cargo run. Get, yeah, blah blah blah. Associate something never used. Shut the fuck up, please. Yeah. So we have the table itself, but it's by far not the most interesting thing. So we have to create, and now the hard stuff, really hard stuff begins. But first, yeah, let me just for a sec go and take a Red Bull. Oh yeah, hello, sorry. Again, uh I took I had to take a Red Bull. Yeah, Tetroflow is basically a Redis alternative, which is because first of all, Redis is a semi-open source, so there is a paid version which has obviously much more functions than an open source one. It's written in C, and I mean in C, not in C++, which could potentially cause a lot of bugs and memory safety issues. So the first version of Tetroflow, yeah, again, it's a very fast in-memory storage. The version I did in C++, I measured the speed, and it was really like it was, I think, like 20, 40 nanoseconds for some operations. So it was like insanely fast. Yeah, so it's a better, faster alternative to Redis, and there are people who are already using some of my colleagues are using Tetroflow for the project. So it's obviously the old version, the C++ version, and yeah. Since I want to learn Rust, I'm trying to maybe rewrite it in Rust. But as a C++ Java guy, it's very hard for me to generally comprehend how the Rust works. I mean, I can understand some features and concepts how it works under the hood. But yeah, again, it's it's very complicated. Yeah, thank you. Yeah, again, I haven't seen any decent Redis alternatives. Actually haven't. All of the alternatives, open source at least. I mean, again, it's semi-open source, right? So, Redis in most applications I've seen. I mean, the plans of the applications. Redis is actually a single point of failure. So there is this. I mean, it's not a huge application, but generally, most of the time there's just one Redis server uh, standing somewhere in the center of the infrastructure, and if it fails, um, I mean, I don't think any critical data would get lost, but generally speaking, it's not that good for the application's performance itself. So imagine you're doing some stuff and you're thrown out because your token can be validated with a token storage on Redis. So it's not good, right? So yeah, and I think the I think replicas you can do only with a premium version. So does it even make sense? Um, yeah, and the other, and they're strongly advocating for their cloud, for their Redis cloud, which first of all one will never ever be as fast as something hosted locally, as we know. So all the latencies, etc. Uh, Even if they say it is as fast, we understand that it's not. It's physically impossible to make it as fast as a native local running Redis. And yeah, that's the first. That's also one of the few things, and all the other Redis alternatives. I've seen a bunch of them. Some of them are actually pretty actively advertising on Google, and actually I seen the advertisement icon. Um, but it always comes to I mean, what's the so if they're writing the open source software and then they are throwing a lot of money to the advertisement. So what's the point? There's no way they're losing money, right? So they should be making profits, or they're aimed to make profits, not to make a good product. So then I started to dig deeper, and at the end, they all the Redis and Redis compatible. I mean, where you can basically put it instead of Redis, it will work with the same Redis API, etc. It will work as fine as a normal Redis, right? But the thing I've seen is they're all trying to sell their cloud. So there is actually nothing but trying to sell your own cloud and cloud features. And they're telling, "Oh, we're blazingly fast open source alternative for Redis." No, you are just the same. You're just the same Redis with a I think some I think they cost even much more than a normal Redis, so it doesn't make any sense. And yeah, what I'm doing here is the point of the thing is, because I'm the one who believes in open source software. I really hope it will. Now there are a lot of scandals. I don't want to go into politics. Mm. The open source community, and it's being actively it decays, unfortunately. But I still believe, first of all, I want to learn the Rust language to maybe, why not, get a job. Um, Especially I have talked to some guys. They wanted to offer me a job. They say if you in some time when I finish the semester at the university, they said, well, you can come over and they will always have something to do. But I mean, Rust, it's a nice language we're using it. So yeah, there's nothing to lose in my case, and I want to keep it as open source and open as possible. So yeah, that's the motivation. So yeah, this cloud UI. Next, what do we want to do? Yeah. So the hard stuff begins now, and the hard stuff is um the hard stuff is the the command. The hard stuff is the commands and the transactions. Um. Yep. So commands, command dot res, and com. Yeah. So we basically have to build out a syntax tree, I guess. By the way, could you be able to make a little bigger so you can see better? I mean, even bigger, right? No problem. Um, I hope. Again, I have a pretty huge display, and even that's this small, I see just pretty fine. But yeah, if of course it's not a problem. So there is a command, which the first thing I want to do actually is wait, there is actually a my official website of the Tetroflow official website. Wait a second. Oh, continue to site. Yeah, it's not protected. Yeah. Blah blah blah. There's some. Hello. Doesn't work. Yeah. There's some AI generated images. Yeah. So these are the docs actually I have for now. Yeah, it's written. Yeah, the old version is in C++. Script GitHub. Nothing but license actually. Oh, SRC. Hello. Yeah, it's actually the whole stuff is here. There's actually a basic replication mechanism here. The gossip replication mechanism. So there's no there aren't any main nodes. They're just nodes. They're just running, and they're just replicating to one another. Yeah. So that's everything. It's C++, and I'm gonna have to rewrite the whole stuff. Yeah. Pretty funny. All the building from source. So it's exactly what the command looks like. Again, the older the actual the alpha version now, the C++ one does not support this is not Redis compatible. The Rust version will be Redis compatible, but basically there is a command, there are some arguments, and now I have to find out how to represent it. How to represent a command. It should. So it should. Let me think. Yeah. Wait. First of all, let me. Yeah. This way. Oops. So there is a command itself, which will get some index signed, I guess. So let's write enum command. Oh, invalid keys clear size contains quit help. Why? Okay. Size clear keys exist till it gets set. Okay, for now it's alright. And can we assign anything? Invalid. It's automatically using the AI. Oh, holy AI. Wouldn't be an engineer without AI. No, it would be just much more complicated than that. Yeah. Yeah. On the other hand, I'm just also sometimes really missing the times where there was like only the code and I had to figure it out on my own, and it's actually a big problem now, the whole AI stuff, because many people are degrading, and I saw this one colleague of mine. He isn't a developer, but he wanted to learn Python, and instead of like learning this stuff by on his own, he was like trying to the ChatGPT to go and write for the code for him, and just ran this code, and he was like wondering why doesn't it work, and I told him, hey, why? I mean, you can't just go ahead and like type in ChatGPT and then say it works, uh, and without really understanding the code and really how it works, because yeah, and the whole people telling me, oh, um, telling me, oh, you know, the programmers will be replaced by the chat GPT. Well, the programmers maybe, but not engineers. It's the first thing. And a second thing, you've ever seen what kind of code chat GPT sometimes produces? Really? Have you seen the code? I mean, that's a total mess sometimes. Oh, I can implement a command. I can implement it. Okay, good. Match. Nice. Can we run it? Oh, yeah, we haven't actually declared this as a mod address. But I gotta admit, I hate the mod call command. I really hate how modules are implemented in Rust. I really hate when I'm forced to use, for example, snake case, because I hate snake case. I normally use camel case or casing. What camel case? You know what I mean, right? Really hate it. Mod commands. So use tables, use command. Does it work? No, it does not. Why doesn't it work? A similar name exists in the module. Wait, let's go for data types. Pub use. Oh, it's declared pub use command. Right. Oh, it should be public, obviously. Enum command. Yeah, no, it's fine. Yeah, but to the rest. Command to the rest. Use the table by itself is a pub, is it? Yes, it is. Right. Good. Yeah, fine. Compiled. Close it for now. Yeah. Command, why is it? I don't actually want to. That's actually good. I've seen a video on it, but what is a between string and ownership and mutability. String is owned, mutable, and growable. String stored in the heap. You can modify. Yeah, like just pretty similar to Java. str as a string slice, which is immutable. View of a string, it's usually point to the part of string or a string literal and stored on the stack. Okay. Okay, memory allocation on state, it's allocate memory and the heap and allows to be resized. That does not allocate, so basically str is just a pointer. It's a reference pointer to the string, and the string it's the holy object himself. Itself. Okay, fine. Let's keep it this way. Okay. Size clear contains keys. Okay, command. So command, I mean, let's call it command type, command type. Just to be sure, right? Okay, to uppercase, it worked. And the command itself, because it's not the command actually which will be executed, it will be a transaction which will be executed, which could contain multiple commands. And until a command is not a transaction is not fully executed, well, there will be no changes made. So what I will do, and what actually my code already does, I mean the C++ version of it, there is there's something smart going on there, and namely it creates a copy of the whole table. So this code creates there is a table, it creates a copy of the table, and it has the original copy of the table. But basically they're both stored on heap, and basically access them only through shed pointers, which are actually smart pointers with control structure, with a reference caller, So it accesses the table copy. It makes all the changes. If an error occurs, it just drops the function and nothing happens. And since in the reference counter to the table copy is dropped to 0, which invokes the destructor. But if everything's alright, to copy the whole stuff over, it just swaps the pointers, and then the current active table pointer is now pointing to the new modified table, and the old table pointer, it's just loses the reference count, and it's just being unloaded with So it's how it works, and I hope I could, and I think I could theoretically try to implement something similar. I hope it works in Rust. I mean, yeah, it's the whole pointer magic. That's actually It's actually the point of the C++. You can do it. That's why the C++. That's what C++ and C are for, right? For these kind of interesting things to happen, but it increases the speed drastically. So I hope. So yeah, command types. Really? Your command and the arguments. But argument is actually a tuple. It's actually a tuple. It's actually a key value tuple. Argument is a key value tuple with being some type determined on parsing string, huh? Oh, so you can is it possible to like write this here? Is it? Well, now it is, but it just lost the old stuff. I mean, now I have to define what kind of command it is. Yeah, but rock. Argument type key value. Okay, fine. Argument. Arguments can be of any type. Exactly a data type. I told not exactly the data type, and it's exactly what it's trying to do. Look, it's stupid as hell. I mean, you could use a hash map. String, huh? I actually don't want to use the string, really. It's like any type. Yeah, so it's any type here. I will just import it. Use. Nope. Use. STD. Where was it defined? STD. Any. Right. Here we go. Then any. So we can use any type here. Right. So we have a command. We have some arguments here. Yeah. Actually, the big question would be: is this? So since it's dynamic, it makes the whole stuff even much more complicated. But the question again would be: is it? Can it be serialized bytes? which is pretty essential for the replication, for the write ahead lock. So yeah, we can serialize the command to bytes and then send further. Let I mean, the biggest problem is that the any is dynamic. Directed to bytes represent trade object and hold any type, make it difficult to serialize generically. Common serialization assert don't natively support box dynamic any because they require knowledge of the compiler time. Oh yeah, that's a decent solution. It's a decent solution. Serialize to serialize. Cert. Yeah, cert. I've somewhere heard it already. Okay. Why? Because the serialize, deserialize, it's just there, isn't it? Integer, text, right, and box. It's the argument value. And also Boolean. Yeah. For now, it's alright, but we will have to add all the lists, etc, etc, etc. Argument value. Yeah. Can get complicated. Okay, let's leave it like this for now. And actually, we're ready now to serialize. Yeah, we'll have to split the file to many other files. Just make a driver onto. Yeah, the compiler's unfortunately a bit slow, but whatever. It's a smart thing. The compiler, it's a smart thing, but it's really drilled. I know, to absurd. Oh, why? It's actually 1 o'clock, and I was thinking, why am I getting tired? And it's just 1:39 at night. Yeah. Well, nice. And for some reason, the Windows clock tells me it's just 9:39. Yeah, maybe I'm not that tired because I drank Red Bull. Time settings. Think now. Yeah, it's 1:39. Yeah. I finished the Red Bull. football, and when I'm really tired, I'll go to sleep. But not before that. Do I even have any viewers? No, on stream. The only viewer is me. Actually, I was just wondering what. Right. Whatever. So I have the command. And now what I have is a yeah, I have to JSON. So I want to try that first with commands, and yeah, with JSON commands, and then I will add a backwards compatibility with Redis. But the Redis protocol itself, it's just it's a horror. It's a nightmare, actually. They're telling it's simple. To some degree it is. Some degree it is simple, but I mean, come on, like using plus and minus as control symbols, and then sending over like plain text and parsing it, and I mean, there's so many things which could go wrong. There's so many things which could go wrong. Certainly, Jason. Yeah. Let's go with the main. I'll just copy some. John Doe. Okay, good. Yeah, I mean it's it's much easier than to parse. It's much easier to parse here than to parse it in C++. Because I mean the only decent library for JSON I found for C++ is uh I think I forgot what N Lochman, I think. NJ Lochman or something. It was something like that, and I mean, in the library, it was a header only library. So basically just a header file, because all the other libraries you had to install. I mean, you had to build it and add the object files or something like that to the LLVM, chain. I'm actually not sure whether wait, GCC CLang uses LLVM, but GCC does not, I think. So to add it to the GCC, you have to do something else. Yeah, okay, it works. It's 30 JSON. T value. Okay. and parse command. Fair enough. So yeah, there's a bunch of code here. Let's hash map new. Um, associated with function name, the current scope or association. Yeah, looks good. Random state. What the hell? Arguments. Okay. Arguments map as object. I mean, yeah. It works fine because it's seen that there is that's the command. That's what it looks like. Turn quick command and some arguments. Yeah. Argument value, value. Right, argument value text. Value bool. Uh, uh, yep. I mean, looks correct, but correct. Sorry, I thought about this old meme. Non pronuncio correctamente. Sì, corretto. The Inglorious Bastards. Yeah. So strings value it iterates, right? Argument with the value is a number. Integer, if not, it's float, right? Okay, good. It's a text and then it's pushes there. Okay. Bool beep dot to owned, right? Okay. Oh, to owned. I mean, I guess it's something like it's something similar to what I did. It's just copies and make sure the command that the whole scope is really owning the variable and that it's not really affected by the other variables lifetimes. So yeah, boolean, and if it's array, then it pushes it box new item clone. That's huh. Well, wait a second. Parse. Let's parse. JSON. Uh, value. If it's a number, right? To an argument value. Okay. Yeah, so that's actually what I wanted to see. I wanted to make it recursive. I mean, on high performance systems, recursive calls isn't the best thing to be fair, but yeah. pub pen. Parse JSON command to command. Okay. Yeah, and it looks fine. Looks fine. Yeah, it looks fine. So let's try to parse something. Oh yeah, I see the error here. Boolean as bool. Found for reference in the current scope. Method not found. Okay, maybe boolean. Dot. You try to clone it. Boolean. Method. No, there's an error here. Turn. Boolean, right? Yep, we'll be cloning everything. Cloning to be sure. I mean, is it an error? Item as box. Yeah, that looks more like it. Pilot, run, yeah, we can pilot, it's the main thing. So parse JSON command and parse JSON value because well, just let's use the parse JSON command, command type, command value, parse JSON command. It should have been used here. I mean, marked as used, but yeah. Whatever. Marked as used. So. Oh, it's suggesting me the command automatically because yeah, again, it's based on my current Tetroflow version of parse JSON command. I mean, argument value, use JSON value, use wait, commands, parse JSON value, parse JSON command. For some reason it's not public. Well, and parse JSON command. Okay, mod. Oh, oops. Yeah, it's not parse JSON value, parse JSON command. Here we go, and now it works. I have to do it. Allow that code and what was it again? Derive. Oh yeah. Derive serialize, deserialize. Oops, it's not here. It's actually inside the command itself. Derive serialize, deserialize, debug, clone. It's this way, isn't it? Oh, doesn't implement debug. Oh, what the hell? Implement command. First of all, yeah, I want to get an argument. And pub pen to string. Command dot string. Will it work? Items. Yeah, I doubted that. Actually, because key value argument value can be formatted with the default formatter. Key value value dot string. Is it possible? No, it's not. Argument value. Let's implement argument value to string. Yeah. Well, okay. Self.command, which is behind a shared reference. Okay, what? I mean, again, unfortunately, I'm not completely getting how it works. But I know it works. Somehow. Oops. Yeah. The curly braces. Has type command type, which does not implement the copy trait. Command type. Drive the bug, serialize the serial, not the bug. Clone. Clone. Serialize, deserialize. Copy. I mean, what's the difference between clone and copy? I don't see. Okay. Comment value key. Yeah. Well. Command 0 and value hello there key test. Well, it seems to work. Started working on a JSON a general structure, a general command structure, right? Pushed, and it just worked. Yeah, just fine. Everything fine. Yeah, blah blah blah, whatever. It works. And we see it also worked, but I mean, I really don't like the whole stuff here, the whole code to just display the command, to just print it, and to just print the whole thing of string. I mean, we could get two string. And I do not want to copy it somewhere. A command self.command dot to string. I mean, it's even better. Yeah, command set and value. So commands set, yeah. Key value command set key test. Why doesn't it actually use the pack the next line? Why doesn't it use it? Yeah, I really don't understand. Maybe it's some kind of security? Maybe not. I mean, to prevent kind of console XSS injections? come on, I really don't know how it works. I really have no idea how it works. Whatever. I don't think I will be actually streaming any much longer. Maybe half an hour max. I don't know. I don't know. It's 2 in the morning now. Yeah, I mean after 2 bowls of Red Bull, I don't want to sleep, but it will be over soon. So yeah, whatever. So yeah, the command force pretty, yeah, it works. It works, and that's the main thing. Extensions, deprecated extensions, create, migrate, whatever. Okay. Dependy empowers developers sufficiently. No, I have no time for that. Don't want to mess with it around now. JSON command. Good. So we are accepting the JSON commands, and now we have to command $s, and now maybe we have to create something else. It's called a transaction, which is one of the key components in a database management system. Even though it's not a normal, it's not a normal database DBMS by itself. A transaction is pretty important, you know, with all the rollbacks and so on and so on and so forth. So let's call it transaction. Transaction. Transaction.res. Again, I will create all the mod files and all the inclusion files a bit later. Here I just wanted to oh, it won't be possible. But I think because wait a second. Not table. Oh, it will be possible. Yeah, so we will be using the data type here. Hash map, the transactions also use create commands, command type. It's fine, is it? It's fine. Yeah, let's load that code for now. Oh. Yeah. So, rocked transaction. Yeah. There's a commands there, and this is the oh yeah. And the pub in transaction type begin commit transaction state state pending committed and abort. Yeah, I don't actually know how to do I have to throw the transaction the abort transactions away, or what do I have to do to the transactions if they are kind of, well, not active anymore? Do I have to throw them inside some kind of queue or some kind of vector or some kind of, yeah, again, first thing, for now it's pretty simple what we're doing here. It's everything single threaded, but not for long, because we'll after we're ready with transactions, I don't think it will be today, we'll be moving to tables. Sorry, oops, microphone. We'll be moving to tables, and if the every table will have its all thread, which has to borrow something and release something. Yeah, so it will be much more complicated, and then we'll have clients, with every client being its own thread again. Or maybe maybe actually we can. Oh no. Well, we'll just rely on maybe Tokyo threads. I mean, I've heard that there may be, as I know, they're the fastest out there. Oops, sorry. And in our case, it's something something what matters. Top state. No, I don't want this to be pub or whatever. Commands, right? And the command. Um, so a transaction. Uh, yeah, and the transaction itself. It's the transaction is pending at command. Okay, push. And from commands and from I mean from this are we it's snake case, don't we? From from single command. Yeah, just pushing it with command. Okay, execute it. Abort printing transaction or command. Okay. We'll be leaving it for now. Unimplemented. Cannot implement it yet. Okay, for now it's just fine. For every and then if it's state, it will be the mutable self transaction will be on the table. Yeah, now I have to ask the ChatGPT how to do it best way. In yeah. So yeah, what I would like to do here is to create here a there is a table reference, the reference to the table, and if the transaction exited correctly, it will be it will replace the it will just swap the pointers and the alt table will be dropped and the main table now will be the updated table here, which and this function won't be run anymore because it just exited, it's popped from the stack, and now we have the updated table. Again, that's how I implemented it in C++. Does it work this way in Rust? I have no idea. Again, I hope it will work in Rust this way. But I can't promise anything. So execute and yeah, for command unimplemented execution. Right. Good. So we have this stuff where this is created and the table. Okay. Now the transaction. I mean, a table will have a bunch of transactions, and maybe can I pass the reference to self in this case? Oops. No, 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 no. New file. No, thank you. Uh, if a table has a list of transactions, transaction, needs pointer to a table execute a transaction with a pointer to self. Can it? And yes. Oh, so it can. Uh, pending. Okay, okay, okay. Good, good, good. Table mutable execute transaction mutable self transaction execute self. So it works. So I can indeed push the pointer. I mean, the reference to itself. I mean, in C++, I had the trouble doing that. I gotta admit, I had trouble doing it in C++. I mean, I had to reference pointer itself, and this is why I actually started considering Rust, because there were some serious complications doing it. But if I can do it here in Rust, it's fine. I mean, it's fine. It's good. It's good. At least something good about this language, because I still have no idea what I'm doing here. I mean, just a bit, but yeah. Let's take a look at it. Let's not judge it by yeah. Let's just see what we can do about it. Right. So execute command execution. Not implemented it now. So the table kinda has a table of the res. Rust. Oh, Rust. You. Um. So again, Rust is a concurrent safe language. Wait a sec. Uh, yeah. Beta to the all. No. So yeah, guys, I think I will go now, and yeah, thanks for watching, and see you next time. Bye bye.